Hey guys, it's Superior and welcome to C++ tutorial number 32. In this tutorial we're going to be looking at finding the address of a variable, and this is important for something we're going to be, for the next topic we're going to be looking at, which is pointers. Now I'm not going to explain pointers in this tutorial, because I don't want to. I don't want to. I just want to talk about addresses, and I'll explain pointers in lots of detail in coming tutorials. But one thing we're going to need to know in order to learn pointers is how to find the address of a variable. And the reason I'm doing this in one tutorial rather than punching in with the other is simply because I felt like doing a short tutorial, which is 5 minutes, rather than 20-minute ones I'm probably going to do tomorrow, which is the one on pointers. Annoyingly, I'm back in school now. Easter break is over, so no more lazing around at home, unfortunately. But yeah, actually I got a new IT teacher, so that's supposed to be pretty cool. We're going to be doing some new stuff with him. Just for everyone who's wondering, in my school we don't have computer science classes and everything. We just have IT, which is really boring. It's just learning how to use Word and stuff, okay? So really the basics, and it's super boring and I hate it. But the new teacher we're going to have this term is supposed to be doing some cool stuff with us, so looking forward to that. Got my first lesson tomorrow. But anyway, enough babbling from me. Let's get on with the tutorial. Let me just do this quickly. Okay, so when we look at pointers, what we're going to need to do is be able to find the address of a variable, because pointers, I'll just say this now, I'm not going to explain why though, pointers hold the address of a variable. So in order to make pointers and make them useful, we obviously have to know how to find the address of a variable, because they're the things that hold the address of a variable. So really simple, this is a super quick tutorial. To find the address of a variable, you just use this ampersand operator, which is it's called the address of operator, just in case you can't hear my pronunciation. Address of, like that, okay? And it simply finds the address of a variable. So here we have an integer called anum, and it's unassigned at the moment, so it's null. And I'm just going to output the address of the variable anum, and I'm going to assign something to it, and I'm going to output the address again, just to show that a variable keeps the same address no matter what value it has inside. You can see these two addresses are exactly the same. Now, one thing I want you guys to know is that when you end a program, or when you go out of a function, I know we've talked about this already, in fact ending the program is going out of the main function. So basically whenever you go out of a function, or whenever you destroy variables yourself, we will talk about that, and we'll talk about that with pointers, because there is actually a case where you can do that, but also with classes and stuff. But ignore that for now. But whenever you go out of a function, or whenever you destroy the object yourself, that memory address is freed up. So when we end the program, i.e. go out of main function, this address is freed up. So actually every time we start the function again, it's going to be a different address, okay? Because that address, the original address, is freed up, and some other variable takes that address, and we get another address that the computer assigns us. So yeah, as you can see, these are always different, okay? If you run it 1,000 times, well, not 1,000, you have to run it like 1 trillion times, seriously. There's so many memory slots in your RAM and stuff, that you'd have to run it trillions of times before you've even had a chance of getting the same address again. So yeah, that's really simple. All you have to do to find the address again is use the address of operator, which is the ampersand, and put it before the variable name. So in this case I have a variable called anum. To find the address I just put ampersand and then anum, no spaces. And it's the same for all variables. So for a boolean variable, a bool, okay, it's the same, and oops, where is it? There it is. A bool. Okay, and for strings, a string, just copy and paste this, a string, there we go, and finally I'll just do characters, a char, actually I've got it on, there we go, a char, and did anything? No. Okay, good. Just need to include the string header because I'm using strings. Compile this, and okay, a char doesn't actually have an address. Actually, it does, but it's hard to explain, so I won't explain it now. But you can see all these addresses are different. So the first two are the same because they're both anum, but the other two are different. Okay, and if I run it again, they'll be different again. But one thing that you should notice is that they're all in similar spaces. Like this one is in 0016 FE00. This one is in 0016 FD F7. This one's in the same but CC as opposed to F7. I'm not entirely sure about this. This might be completely wrong, but I'm pretty sure these look like hexadecimal characters. That might be completely wrong, I don't know. I'm just guessing, because it does kind of look like it, you know, 0 to 9, A to F. But anyway, I'll research more on the address of a character, because actually, for me, that was a surprise. I thought it would have an address, so I'll look that up. You know, I'm not a pioneer in C++, guys. I just want you to know that. I mean, I've got enough so that you guys, when I teach you, should be getting the right information. You know, it's not going to be bad information, but I don't know every in and out, you know. So you'll just have to bear with me there, I guess. But I will look this up. I'll check out what's going on with this, and hopefully I'll get back to you on the next tutorial. Anyways, guys, over now.